Okay, so I've got a garage door, 200 pounds. Got springs on each side of the door as shown here. They got a stiffness of 50 pounds per feet. It is unstretched when the door is in this position right here. Okay, I release it. I want to find the velocity when that thing hits the floor. Okay, so again, all I've got going on here is that those two springs. There are two of them, one on each side. You can only really see one, but just recognize there's two of them. And then gravity pulling that thing down. So because of that, we're going to say KE1 plus PE1 equals KE2 plus PE2. Okay, so again, it starts at rest. This guy goes to 0. Okay, we're going to call this our datum. So we start at 0 potential because, again, the springs are unstretched, as well as me calling my 0 datum at that point. So really all we have is the final. So again, KE2 equals, now at this point, this thing is perfectly vertical, so it's only sliding up and down, right? So there's not going to be any rotation at the end point, right? So it's at that instant, it's only translating straight down. So I only have the 1/2 mv squared on this. So that's going to be 200 divided by 32.2 to get to mass. And then v squared, which is what I'm looking for. And again, there's no rotation at this instant because it's at that instant it's just going vertical, just straight down. It's in that straight part of the guide there. So moving on to PE2. Okay, so now at this point it's fallen. That would be 9 feet, right? So, and it's fallen below that, so I'm going to say negative 200 pounds. Oh, actually, it's not going to fall 9 feet. It's going to fall, it starts at 9 feet and actually ends at 4 feet because it ends, right here. Whoops. Come on. In the middle, right? So that's actually 9 minus 4. We'll do it that way. So it's actually 5 feet that it falls because, again, it's to the center of gravity of that guy. Okay. Then I also have the spring force. Okay. Now the spring is attached basically to the end of A. There's two of them. Springs always have positive potential energy, so I'll say plus 2 1/2 K is 50. Now the thing is the stretch in the spring. Notice that, A moves down 8 feet, but the way the pulleys are set up, that spring only moves 4 feet, so it's going to be 4 squared. And really, that's all there is to it now. Okay, because I basically get now 0 equals 3.11 v squared minus 200. And from that, I get the velocity is 8.02 feet per second. So again, recognizing that you just have springs and gravity, we can use conservation of energy to solve such a problem.